Hello everyone, I'm Charis, physics teacher of Senior 6. So here we are going to discuss how sound waves propagates, but also what are the factors that affect velocity of sound waves. Remember, we have said that sound waves propagate with a medium. They are different from electromagnetic waves because sound waves, it is in the range of mechanical waves. Mechanical waves, these are the waves which needs medium for propagation. Now, there are some factors that affect velocity of sound waves. You may guess, what are these factors? Very simple. So, factor number one, we have what you call compressibility. What does it mean, compressibility? If you understand very well sound waves, it is very simple. Remember, we define as vibration of medium to mean if there is a compressibility, if there is a rarefication, there is production of sound waves. To mean, as long as the medium is compressible, this will affect the speed of sound waves. Let me ask you an interesting question. Where do you think sound waves can propagate faster? In solids, in liquid, and gases? The answer is in solids and in liquids, they are propagating very faster than in gases. Most of us, we may think that it will propagate in gases. No. Because there is a vibration. As long as in solids there are some molecules, these molecules will vibrate, then that vibration will allow this speed, density. Now, this one is going to help you to understand compressibility. Because as long as something is compressible, still it will have that density. If the density is high, we shall see the relationship between the compressibility and the density. We have also the temperature. The temperature. Temperature affects propagation of sound waves. Let me help you. Let's take an example. If you are boiling water, intermolecular forces between the molecules, they are far apart when they are hot. But if what is cold, to mean the compressibility still will be high as long as the temperature is low. So we shall see the formula which is going to understand very well this compressibility. But some of you may ask yourself, why you have not said pressure? That's a great question. Wonderful. But sorry to say that pressure will not affect the velocity of sound waves. Let's talk about this compressibility. Speed will be equal to the square root of Birk module divided by the density. Now, I'm coming with another technical term that we are using in physics. Birk modulus. B to mean bulk modulus. This is a constant which shows how the liquid is compressible. And remember, we are using Birk modulus for liquids, for fluids. So the speed, as we said, that is equal to the square root of Birk modulus divided by the density. Now, what is Birk modulus? This Birk modulus, let us write it. Birk modulus it's a constant to show how a liquid or a gas is compressible. So Remember, for solids, we don't use big modulus, we use Young's modulus. Then in solids, speed will be equal to the square root of Young's modulus divided by the density. Okay, so for this, that's for liquids and gases, but this is for solids. This is for fluids, to mean gases and liquids. Now this is law, that is the density of the material, then big modulus, then this y, that Young's modulus. Okay, to mean these two formulas as how to find the velocity of sound waves by using big modulus or Young's modulus and the density, to mean we are just combining these two. Wonderful. Don't you see that is very interesting? When you have two factors, you are combining them into, you are getting one formula. Now, let's talk about the temperature. How temperature affects the velocity of sound waves? Very simple. We have, for temperature, we have the speed is equal to the initial speed times the square root of temperature divided by the initial temperature. What does it mean? To mean, if you have the change in temperature, the final velocity of a sound will be equal to the initial velocity times the square root of the final temperature over initial temperature. Now, you may ask yourself, now, if you are saying initial velocity, what does it mean? Am I going to give the speed or the velocity to the sound? No, like in the air. The V or in air is equal to 331 meter per second. Okay, that is in air. Now, this is the final temperature. This is the initial temperature. You can see that there are three main factors that affect velocity of sound waves. And remember, sound waves, they are waves which needs medium of propagation. To mean, they can propagate in air, they can propagate in solids, but also they can propagate in liquids. Not only in air, but also in other gases. We have said, what about pressure? Let me help you to understand it. So, please note that the change in pressure do not affect the velocity of sound waves. Very interesting, because you may ask yourself, how temperature did it affect the velocity, how compressibility, how the density. But remember, pressure will not, the change in pressure will not affect the velocity of sound waves. Now, let us take an example of where you can use these formulas. So, but by next video, I'm going to show you how to apply these formulas, how to apply these factors, but in a mathematical way. Because remember, in physics, we are dealing with the theory, but also practical parts. When I'm using the formula, that is helping you to understand that the first two factors can be combined in the formula, but also have another formula for the third one, where we have temperature. For more details, please like, visit our YouTube channel, which is Ikaram TV. Ikaram TV. But also can visit our website where we have the content for these units, sound waves, but also you are going to find other units for senior 6 according to Rwanda Education Board curriculum. You can find it www.ubumenyi.net. Thank you very much for watching this video. It is helping you to understand factors that affect the velocity of sound waves. Ciao, ciao. Thank you.